Okay, well the first thing you have to understand about an orbital, it's a region of space that is occupied by electrons. It can be occupied by either 0, 1, or 2 electrons. And so let's just try this. Okay, so for instance, the s orbital holds 2 electrons. So that means it requires 1 orbital. We're just going to use a dashed line to represent an orbital. It's just a way of keeping track of the electrons. Since you can have 2 s electrons, you can have 2 electrons orbiting in this one orbital. Now the thing is, though, electrons have a quality about them, a magnetic property called spin. So if 2 electrons occupy the same orbital, as in 2 electrons occupying this orbital here, they have to have opposite spins. And the way we represent these spins is by using an up arrow or a down arrow to represent an up spin or a down spin. It just means opposite magnetic attractions. So in the case of this s orbital here, an s sublevel, we need 1 orbital because we have to have up to 2 electrons, and I'm going to draw them this way. The first electron we'll draw with an up spin, and the second one we'll draw with a down spin. So this shows a filled s sublevel that has an orbital that has 2 electrons in it. Now let's move on and look at p. So since p's can have up to 6, so if you think about it, you can have up to 6p electrons. If each orbital holds 2 electrons potentially, that means in order to accommodate all 6 of these electrons, I'll need to have 3 orbitals. So I'll draw that with 3 lines. 1, 2, 3. Each one of those spaces that I've drawn represents an orbital, and that orbital can be occupied by 0, 1, or 2 electrons. So let's just say that I have a electron configuration in which I end up with a P2. So I had to park 2 electrons in the P sublevel. The rule is we're always going to occupy it with up spins first. We could use down spins, but in my class I like to say let's just use up spins. Now I cannot put 2 up spins in the same orbital. That simply won't work. So that right there is no good. So instead what I would do is I would put 1 electron with an up spin in this orbital and 1 in one of the other orbitals. It doesn't really matter which. I always put it in the next one. But that's how I would represent P2. Now if instead it was, let's just say it was P3, in other words I had 3 p electrons, the third one would also have an up spin and would be put in that third orbital. Similarly, if I had to park P4, so I have 4 electrons to put in the P sublevel, I'd put 1, 2, 3 ups, and now I have to start to double occupy. So I'm going to put in the next one with a down spin. And I like to describe it like seats on a bus. If there's an empty seat on a bus, you're going to take that first. You don't want to start double sitting on a bus if there's an empty seat available. But once there is, that's what we'll have to do. So once they're all taken, so if I have a P5, then that'll be here. And if I have P6, it will look like that. So now let's look on at D. So for D, if you remember, you can have up to 10 d electrons. So that means I need to have 5 orbitals because each can hold 2. 1, 2, 3, 4, 5. And if I go to occupy those orbitals, D1 would look like that, D2 would look like that, D3, D4, D5. I'm out of empty orbitals, so that D6 would look like that, D7, D8, D9, and D10. And similarly, since F can hold up to 14, 14 divided by 2 gives me 7. I need 7 orbitals in order to house all of those. 1, 2, 3, 4, 5, 6, 7. Now here's the thing. When I'm drawing an orbital diagram, even if I just have 1 F electron, let's just say I have F1, I still have to draw all 7 of these. I have to show the empty orbitals as well as the occupied orbitals. So I'm going to show all 7 of these, and I'm going to occupy it with a single electron. Seems like a waste of paper, but that's what we're going to do. So let's go on and look at our lesson. Okay, how many orbitals do each of the following sublevels have? Remember, you can have 2 s electrons, so you need 1 orbital to hold them. You can have up to 6 p electrons, so you'll need 3 electrons to house those. You can have up to 10 d electrons, so you'll need 5 orbitals. And you can have up to 14 f electrons, so that means you'll need 7. you basically need half as many orbitals as you have electrons possible, because each orbital can hold 2. As you see from this diagram here, an orbital can be empty, it can have 1, or it can have 2 electrons in it. So let's go ahead and try doing silicon. Now, the thing with silicon is, the first thing we're going to do is we want to do a, actually the first thing I'm going to do is make this a little bit bigger. Okay, so let's try doing silicon here. First thing I'm doing is electron configuration. So if I did an electron configuration for silicon, it's the same as neon. And then after neon, I would have 3s2, and then I would have 3p2. So when I go to do this, the orbital diagram, I do just like the electron configuration. I say bracket Ne, just like with the electron configuration. Then, what I'm going to do is I'm going to represent this 3s orbital just by simply writing 3s here. So this represents an orbital, a 3s orbital, and now I'm going to put in these 2 electrons. One has an upspin, one has a downspin. Now that orbital is filled, so I move on to the next one. Now the next one is a 3p orbital. Now remember, p orbitals can hold up to, the p sublevel can have 3 orbitals, so I have to show all of them. So I'm going to bracket this, bracket off 3 of them, and label these 3p. And now I'm going to occupy it with 2 electrons. Here's 1, and here's 2. Notice they both have upspins, and they're not sharing an orbital yet. Think of it like seats on a bus. There's no reason you're going to both stay on this seat here when there's extra seats available. First you fill all the seats before you start double filling them. So let's do cobalt now. So the electron configuration for cobalt would be this. It's AR followed by 4s2 3d7. So to do the orbital diagram, I say AR. Now I'm going to show the 4s sublevel, and I'm going to occupy it with 2 electrons, 1 upspin, 1 downspin. There's my downspin. Alright, now I'm going to move on to the 3D. Now remember, you can have 5D orbitals, so I had to show all 5 of them. 1, 2, 3, 4. There's 5 of them, and I'll label it 3D. And now I have to occupy it with 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, so this is the orbital. This is the electron configuration for antimony. So we just want to turn that into an orbital diagram. So we say bracket Kr. Okay, we just took care of, what's that, like 36 electrons? Alright, the next one is going to go in the 5s sublevel, which needs, since there's 2 electrons that fill out, I need 1 orbital to do it. 5s, and it's occupied by 1, 2 electrons. Now we move on to the 4d. Now remember, since you can have up to 10 electrons in the d's, you need to have 5 orbitals. 1, 2, 3, 4, 5. We'll label that 4d, and we'll occupy it with 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we move on to the 5p. Recall that p's can have up to 6 electrons, which means I need 3 orbitals. So I have 1, 2, 3. I'm going to label that 5p. And we have, how many electrons do we need to park? We have to park 3 of them. So we have 1, 2, 3. Alright, let's do osmium. Here we see this is the electron configuration for osmium. So we're going to start off just like with electron configuration by bracketing off using xenon. So here we have Xe. What's that, 54 electrons, I think? Alright, and so then this will be the 6s orbital occupied by 2 electrons. Now this will be followed by the 4f. Recall that we have 7f orbitals per sublevel, per f sublevel. So I had to bracket off all 7 of those. 1, 2, 3, 4, 5, 6, 7, which I'll then label 4f. And I gotta occupy all of them. Kind of a pain, but here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we have the D's. I'm going to move over a little bit here because D's require 5 orbitals. And we have 1, 2, 3, 4, 5. We'll label that 5D. And if you notice here, we have to occupy it with 7 electrons. We'll do ups first. 1, 2, 3, 4, 5, 6, 7. Okay, let's try doing molybdenum. Alright, we're going to start off with a bracketing noble gas configuration of krypton. Now that means we have to move on to the 5s orbital, which is going to be here. We're going to occupy it with 2 electrons. Now we're going to move on to the 4d. Recall that D's have to have 5 orbitals. 1, 2, 3, 4, 5. We'll label that 4D. And we have to occupy it with 4 electrons. We're going to start with upspins. 1, 2, 3, 4. Alright, moving on to selenium. We're going to bracket it off with the argon noble gas configuration, followed by the 4s orbital with 2 electrons in it, followed by the 3d. D's require 5 orbitals. 1, 2, 3, 4, 5. We'll label it 3d. We'll occupy it with all 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll move on to the 4p. There are 3 orbitals in the p sublevel. So there's 1, 2, 3. We'll label it 4p, and we're going to occupy it with 4 electrons. We'll start with the ups. 1, 2, 3, and then 4. Well, here we go. Now we're going to do bismuth, and we're going to see that it's kind of got a long electron configuration. So let's get started. We're going to use xenon as our consolidating noble gas, which is followed by 6s, which, as always, S's have 2 electrons in them. Then we go to the F sublevel, which, remember, that needs 7 orbitals. 1, 2, 3, 4, 5, 6, 7. Is that right? Let's just check. 1, 2, 3, 4, 5, 6, 7. Okay, I did it right. And then we got to occupy all of them. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ugh. After which we have to go on to the 5Ds. Ds need 5 orbitals, so we need to bracket off 5 of them. 1, 2, 3, 4, 5. We're going to go ahead and label that one 5D. Hey, what happened to my 4F? There it is. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Good golly. Now I'm going to have to move this whole production sideways, and whoops, I'm missing some. So let's just go ahead. I have to still do my 6p. I don't know what's with this sheet here. I got to go ahead and draw these. I'll do this one here. I should have 1, 2, 3 more orbitals to fill. So I'm going to bracket those off, and I'm going to label those 6p. And I have to occupy it with 3 electrons, and that's going to be 1, 2, and 3. And finally we have americium, which we are going to use radon as our consolidating noble gas. We got radon there, and we follow that up with the 7s orbital. So here we go, 7s. It looks like, as always, 2 electrons, so we're going to put 1 up and 1 down. After that, we move on to the 5f sublevel. F sublevels have 7 orbitals. So we go 1, 2, 3, 4, 5, 6, and 7. Here we have, and that's going to be the 5F, and we have to occupy it with 7 electrons, and we're going to just use all ups. 1, 2, 3, 4, 5, 6, and 7. There's your homework. Hope you enjoyed as much as I did.